Here we have a little more on this idea of modularity and building these units. Here we have this rack sitting in a container, a shipping container, standard. This was designed, the size of a shipping container was designed around the size of roads, the size of engines, and what cornflakes needed. But that now defines the unit of computing. It's the shipping container. And so it shows how, making progress requires building on other technologies, because this is the commodity world. Cloud computing is enormously expensive. It has to make use of economies of reuse of technologies from other fields. Here we have an actual picture of this showing here we have all the linkage points for the containers, and here we have a little picture of how these containers are carefully aligned in a fashion they can be taken in and out conveniently. Presumably, if enough nodes fell in the container, you haul up your truck front end and drag it away and send it back to the place which mends containers. I don't know whether it's an industry mending containers or it's all just done by the same companies that build the systems in the first place. Here we have again, these are Microsoft slides, because Microsoft's actually a little more open about what they do than some of the other companies. Google's especially mysterious, and Amazon is pretty mysterious. So here you had the various form. At this time was probably changed now. This was 2012, around May. So that's almost 2 years old. They at that time had 4 centers in America, 2 in Europe, and 2 in Asia, these 2 major ones. And here's some presumably content distribution network nodes, which are sort of subsidiaries for aggregating traffic to these cloud centers. Here's some comments on greenness. In that 2006 survey, I believe that the average so-called PUE, which was the ratio of the power used by this facility and the power that actually does computing, which was used to be 3, is now actually getting nearer and nearer, 1.1. And around 2010, it was actually 1.8. So it's just drastically decreased. And that is partly, clouds have just shamed everybody else into making it better. And so here we showed you the 4th generation, which gets away, makes everything as modular as possible. There's a link for that here. And the 3rd generation is that container-based systems we actually gave a picture of at Chicago. It's very difficult to find out actually anything quantitative in some areas on the web because it's all secret. Google only indirectly told us in 2010 that they had around 1 million servers because they told you something about electricity use, about how good they were, and indirectly told you in that fashion how many servers they had. So in 2010, there were around 30 million servers worldwide, and Google had 3% of the world's servers. And Google actually had 3% of the servers, but used less than 1% of the total power because Google's far more efficient on average, as I pointed out. Clouds are around 1.1, and this says in 2010, if you average over everything, which includes some catastrophes, it's over 3, the PUE of the standard server. So at this stage of 2010, I estimated clouds were 20%. Obviously now maybe nearer 30% of the total server count, because they keep on. You remember I had on the last unit I had comments on the size of Amazon Web Services and their revenues. The revenues drastically jumping corresponds to the number of computers drastically jumping. So, because they're helped by having big tenants like Netflix must have a lot of computers being used to stream all those movies. Here is this, remember we had 30 million total in 2010? Well, here's an estimate in 2014 to 15, another 10 million servers we added to cloud. So that 30 million ain't going to be 30 million. Um, and Actually, here you can see, this is a 2013 August talk. We have 5 US centers for Microsoft, 2 in Europe and 3 in Asia. There were 2 in Asia, 2 in Europe, 4 in the US in the slide before. Um, this is a comment here from Dennis Gannon on some of the important areas, such as deep learning, which is revolutionizing natural language translation and face recognition and things like that. Remarkable. And lots of interesting biological. Here, there's the gene-wide association studies. This is all AI and machine learning. Those are the nuts and bolts of the cloud. That's the analytics part of the cloud. If we want to look at sizing, then when this was written, the largest advertised cloud computing centers were 100,000 servers. Now we expect them to be nearer a million. And that's what it says here. 2014 will be a million. So the largest supercomputer, which actually no longer is Sequoia, but it's the second largest. China has the largest. This is still, I think, the largest in the US, the Sequoia machine. It has a million chips, which is, you might say, 100,000 chips, 1.6 million cores. This is a so-called Blue G, which has whatever, 16 cores per node. It has pretty small cores. It's unusually small, very, very efficient, compact supercomputer system. And it had 8 megawatts of power. It's very efficient power-wise. And still, it's only 50,000. If you take a typical server with 2 nodes, it would correspond to 50,000 of those. So it's not so big. So I would say the largest supercomputer is at best 1% of the total computing system. Here's some more details, a comparison between data centers and supercomputers. So we have 100K servers in Chicago cloud, and that's actually 2,000 servers per container. A little different from the estimate I gave before. I think I said up to 1,000. So this is 2,000. And that Blue Waters, which is another supercomputer I gave you, Sequoia, which was 50K. Sorry, but it's actually in terms of no, it's 50K 32 core systems, because it was 1.6 million cores, 100,000 nodes, and if you arrange that, I don't think this is how Blue Beam is packaged, but you arrange them as most systems are, commodity system as 2 nodes per 2 chips per node, then you get Sequoias in this 50K number, just has more powerful computing power. So anyway, here we have supercomputers, 50 to 100K servers, but we have a single data center is the same size, and let's say Microsoft is now going up to 1 million. The network architecture is pretty different. Supercomputers are optimized, but for bandwidth between nodes. Data centers are optimized the bandwidth to the internet, because clouds are connected to the internet. So data centers make a lot of use of in-memory caching, this memcache technology, which is an example of the in-memory database. Whereas supercomputers typically have a separate data farm and some methodology like GPFS, which is the parallel file system, to link the data farm to the supercomputer. So here we have the data center network, relatively simple. Here you have a fancy fat tree network, which is how you do supercomputers. These are optimized for high bandwidth, low latency between the nodes of the supercomputer. So now we're going on to applications. That's the end of our architecture study. Let's go on to this next lesson. Thank you very much.